Solving systems of equations by substitution. We've already talked about how difficult it is when we're using grafting to be able to determine what our exact ordered pairs is. So actually the only way we can really do it is when we actually check. So of course we come up with a different methodology, a different method here, and it's called substitution. On page 390 in your textbook, it gives us 5 different steps that we must follow in order to be successful. Step 1 says to solve for one variable in at least one equation if necessary, and in this case we have y, and think about these literal equations here, guys. Y is equal to x plus 3 and y is equal to 2x plus 5 is already solved literally. So all we need to do now is go to step 2. It says substitute the resulting expression into the other equation. We're talking about the expressions on the right side of the equal, not the entire equation, just the expression on the right. And so let's take y is equal to 2x plus 5 and substitute the expression x plus 3 for y. That's going to give us x plus 3 is equal to 2x plus 5. You might have noticed I've already done this prior when we were checking in grafting. So okay, and here we will take our like terms and combine our like terms, and let's start by subtracting 5 from both sides. So this will give us x, too close to the corner here. So back to the old drawing board. That would give us x plus 3 minus 5 is equal to 2x plus 5 minus 5. Okay, on the right, our 5 minus 5 is going to cancel out. That's just going to give us 2x, and here we'll have 3 from a negative 5. It's going to give us x minus 2. Okay, look closely how I got that, is equal to 2x because the 5 cancel out. So here let's take and bring x over here, because again we don't want that negative. We don't want that negative. So let's subtract x from both sides. So that'll be x minus 2 is equal to 2x minus x, and x from x is 0, so that'll just give us a negative 2 on the right is equal to, and 1, coefficient 1 minus 2 is going to give us x. Okay, so here we go with our very first variable, which is x value for a variable, which is a negative 2. So now it tells us to substitute, guys. Substitute the equation into one of the original. Let's take the easiest one. It's always good to take the easiest one, and go ahead and change colors here. So here we will take x plus 3, and it says x is a negative 2, so we have y is equal to a negative 2 plus 3. 2 from 3 is 1, so here y is going to equal to 1. And then it says write 3 and 4 as ordered pair. So my ordered pair will be negative 2 comma 1. Tells us to check it, so easily we take our ordered pair and go ahead and put our ordered pair in for either one of our values. So check, we will take either one of our values. So let's take x plus 3. So y is 1. 1 is equal to a negative 2 plus 3. 1 is equal to 2 from 3 is 1. So it does check. So apparently negative 2 and 1 satisfy that system. Alright, so let's hurry along with here and take a look at the second one. The second one. Right. Okay. So here again we go back to our steps. We need one literal equation solved already. We have x is equal to 2x plus y. So now we just need to put x in the expression 2y minus 4, I'm sorry, in for x. Okay, so again, x is already literally solved here. X is equal to 2y minus 4. We need to just substitute 2y minus 4 for x. And that's going to give us, in this equation, it's going to give us 2y minus 4 plus 8y is equal to 16. Let's go ahead and put constants over on the same side, and we will add 4 to both sides doing that. So that's 2y minus 4 plus 4 plus 8y is equal to 16 plus 4. And here that will give us 2y plus 8y is equal to 20. Adding like terms on the left will give us 10y is equal to 20. And then we're going to divide both sides, the 10 and the 20 by 10. So that'll give us 10y divided by 10 is equal to 20 divided by 10. And y is going to equal to 2. So now we've gotten that. It tells us again, it said, listen, make sure that you go back and put in your ordered pair, x and y. So, well, actually, let's get that far. So we knew that y is 2. So let's go ahead and substitute that in the very first one. It's easier to do. So that's going to be x is equal to 2 times 2 minus 4. X is equal to 4 minus 4, and it says x is equal to 0. So okay, our ordered pair here is 0, comma 2, and we'll go and check it to make sure that we've gotten the right thing here. So let's check, if you don't mind. CHECK, we'll check here, and it tells us, and using the very easiest one, which is x, go ahead and say x is equal to 2y minus 4 is the very easiest one. X is 0. 0 is equal to 2 times 2 minus 4. 0 is equal to 4 minus 4, and 0 is equal to 0. So again, 0, comma 2 is a solution. All right, hurrying right along. We're fighting for all the time here. As I can see, part of my equation have slipped away here. So this should be x plus y here. All right, so we go ahead and fix that little problem. So we got x plus y is equal to 7 and 2x, and then neither one of these. So now we got to take something. So let's go ahead and let's a little arrow here and a little arrow here. And what we're going to do here is we're going to subtract x from both sides, and that's going to give us actually y is equal to a negative x minus 7. Okay, and then we can go ahead and put our 2x plus y is equal to a negative 4. We can go ahead and put that. So again, I created here, if you need me to show you how I did that, I just subtracted y from both sides, and that's going to make subtracted x from both sides. It's going to leave me y, and then negative x minus 7 on the left side. So let's go ahead and quickly solve. And it says step 1 is, since you have y is negative x minus 7, we can plug it in up here, and that's going to give us 2x plus, in parentheses, a negative x minus 7 is equal to a negative 4. Okay, so that's going to give me 2x minus x minus 7 is equal to a negative 4. We want to add 7 to both sides. That's give me 2x minus x minus 7 plus 7 is equal to a negative 4 plus 7. That's going to give me here 2x minus x, 7's cancel out, is equal to 3. Then when we see Here, combining like terms on the left side, 1, that's a negative 1. 1 from 2 will give me x is equal to 3. Okay, so I have my first one. All I need to do now is take that and substitute it in for my second one. And I'm going to use this x plus y is equal to a negative 3. So x is 3. This is, I'm using x plus y is equal to a negative 7. X is 3 plus y is equal to a negative 7. Subtract 3 from both sides. Negative 3 plus 3 plus y is equal to a negative 7 minus 3. Okay, your 3's cancel. And that's going to give us y is equal to 7 plus 3 is 10. And the signs are negative. It stays negative. Y is equal to negative 10. So again, my ordered pairs are 3, negative 10. Now, check. All I need to do now is take my, so let's go check. No, that don't look good. Look like some of my writing. So let's take and check here. And we will check by using x plus y is equal to a negative 7. It says x is, well, 3 plus a negative 10 is equal to a negative 7. Well, guess what? 3 from 10 is 7. 10 is greater. Negative 7 does equal to a negative 7. So again, all 3 checks. So as you can see, we can use a certain format and solve these systems by substitution. Have fun, and I'll see you.